Speaking about the early life of Homi Jahangir Baba, Homi Jahangir Baba was born in Bombay on October 30, 1909, to Jahangir and Meherbai Bhabha. Jahangir Bhabha had grown up in Bangalore and was educated at Oxford. After receiving his training as a lawyer in England, Jahangir started working in Mysore, where he joined the judicial service of the state. He married Meherbai, daughter of Bhikaji Framji Pandey and granddaughter of the renowned philanthropist Dinshaw Petrit of Bombay. After marriage, the couple moved to Bombay, the first commercial city of British India, where young Bhabha spent his childhood. Homi was named after his paternal grandfather, Hormjis Bhabha, Inspector of General of Education in Mysore. Homi's paternal aunt, also Meherbai, was married to Dorab Tata, the eldest son of pioneer of Indian industry, Jamsetji Nuraswanji Tata. Here at the Tata's ancestral home, the commercial world of his industrial uncle revealed itself to the young Homi. But he also observed the deep bonds that the Tatas had forgotten with institutions of learning, notably the Indian Institute of Science, Bangalore, of which Sir Dorab had taken charge of, following the death of Jamsetji Tata. Homi had his schooling at the Cathedral and John Connell School, Bombay, which he would observe years later, did much to foster his love for science. After attending Elphinstone College and the Royal Institute of Science, both in Bombay, Homi was sent to England in 1927 to the Gonville and Close College in Cambridge and was a scholar of the college till 1929 to 1930. Bhava enrolled for mechanical trios in Cambridge since his father and his uncle, Sir Dorab, wanted him to become an engineer and join the Tata Industries. At Cambridge, Homi's interest soon shifted to theoretical physics and mathematics. He described this passion in a letter to his father in 1928, in which he wrote, I seriously say to you that business or a job as an engineer is not the thing for me. It is totally foreign to my nature and radically opposed to my temperament and opinions. Physics in my line, I know I shall do great things here, for each man can do best and excel in one thing, that thing of which he is passionately fond, in which he believes, as I do, that he has the ability to do it. He is in fact born and destined to do it. Besides, India is not a land where science cannot be carried on. In another letter, Homi writes to his father, I am burning with a desire to do physics. I will and must do it sometime. It is my only ambition. I have no desire to be a successful man or the head of a big firm. There are intelligent people who like that and let them do it. It is no use saying to Beethoven, you must be a scientist, for it is a great thing, when he did not care two hoots for science or to squarettes, be an engineer. It is the work of an intelligent man. It is not in the nature of things. I therefore earnestly implore you, let me do my physics.
Further studies, his father agreed to let him pursue theoretical physics, enroll for the mathematical tripos, provided he devoted himself first to his mechanical tripos and got a first class. Baba achieved that in July 1930 and was free to devote himself to his interest in theoretical physics. His initial interests were mainly in positron theory and cosmic rays particles. At Cambridge, Baba joined the Cavendish Laboratory, from where he obtained his PhD with R.H. Fowler as his thesis supervisor, work in nuclear physics. Baba's important contribution during Cambridge period, including the explanation of relativistic exchange scattering, that is Baba scattering, the theory of production of electron and positron showers in cosmic rays. Baba held the theory. Speculation about the Yukawa particle, related to which was his suggestion of the name meson, and prediction of relativistic time dilation, dilatation effects in the decay of the meson. Baba was the first to do a proper quantum theoretic calculation of the process of positron annihilation and creation, one of the basic processes in quantum electrodynamics using Dirac's theory. This process, known as the Baba scattering, is even today used as a luminosity monitor in electron positron collider physics experiments. Jointly with the German scientist W. Hitler, then at Cambridge, Baba explained the cosmic ray shower formation in a paper published in 1937. It had been discovered by 1918 that there is a strong level of radiation in the upper atmosphere. Robert Millikan, who was the first to identify that the origin of radiation was from outside the Earth, called it cosmic radiation. During the 1930s, It was discovered that extensive but short lived patches of high intensity radiation developed in the sky and then die out. Bhabha and Hitler developed a theory of this process by the cascade production of gamma rays and electron positron pairs. A high energy particle from the sun or from some remote source like a star, a galaxy, or quasar. It's the atoms of the upper atmosphere. This hard hit causes the nuclei of these atoms to disintegrate, creating a number of high energy fragments and new particles. These fragments fly off with energy to hit neighboring atoms and cause their nuclei in turn to disintegrate and fly off. This process continues over miles with over diminishing energy till the last fragments in the chain have no more energy to cause nuclear reaction. The shower of fast moving charged particles thus created gets detected as cosmic radiation. Not all the experimental facts about cosmic ray showers, however, are accounted for by the Bhabha-Adler theory. To explain the penetrating component, Baba made the far-reaching hypothesis that there must exist a new particle with the same characteristic as the electron but approximately 100 times heavier. This was an original deduction, and Baba's prediction was soon corroborated by the discovery of Nedemaeser and Anderson. These particles were given the name meson. Today, this particle is called the mount. It is approximately 200 times heavier than the electron. Baba was also the first to point out that cosmic rays moving at speed close to that of light are the best place to verify the consciousness of Einstein's special theory of relativity. For example, mesons which normally decay with a distance of half a kilometer can travel more than 10 kilometers down to the Earth's surface because relativistic time dilation increases their decay lifetime. Baba proposed vector mesons as particles in relation to Yukawa's scalar mesons that would play a role in nuclear interaction. These vector mesons were massive, had spin 1 and odd parity, thus explained the fact that triplet state of d neutron, a heavy isotope of hydrogen, whose nucleus has one proton and one neutron, was the lowest stable state. Baba held the Rouse Ball traveling studentship from 1932 to 1934, during which he visited Enrico Fermi at the Institute of Physics in Rome. During 1934 to 1936, Baba held the Isaac Newton studentship. In 1936, he was awarded a senior studentship at
Returned
the
to
exhibition
India,
of
Bhava came to India for a holiday in 1939, but the outbreak of Second World War in September 1939 made him change his plans. He joined the Indian Institute of Science at Bangalore, where a readership in the theoretical science was especially created for him. Professor C.V. Raman, who was at IISc at that time, was highly impressed by the Homi Bhava. In 1941, Bhava was elected a Fellow of the Royal Society of London. He was awarded the Adams Prize in 1942 for his thesis on the theory of elementary physical particles and their interactions. During his 5 year period in Bangalore, Bhava realized that the difficulties of carrying out research activities in India. He understood that none of the existing research institutes in the country had a facility for the original work in nuclear physics, cosmic ray physics, high energy physics, and the other fortnets of physics. In a letter to his friend J.R.D. Tata, Bhabha wrote, "The lack of proper condition and intelligence financial supports hampered the development of science in India at that phase the talent in the country could warrant." JRD realized the need of a world class research institute for India and suggested to Bhava that he should write to the Sir Dobji Tata Trust for funds to set up a new institute.
Career. Starting his nuclear physics career in Britain, Bhabha had returned to India for his annual vacation before the start of World War II in September 1939. War promoted him to remain in India, and he accepted a post of reader in physics at the Indian Institute of Science in Bengaluru, headed by Nobel laureate C.V. Raman. During this time, Baba played a key role in convincing the Congress Party senior leaders, most notably Jawaharlal Nehru, who later served as Indian Prime Minister, to start the ambitious nuclear program. As part of this vision, Bhabha established the Cosmic Ray Research Unit at the institute, began to work on the theory of one particle movement, while independently conducting research on nuclear weapons in 1945. In 1945, he established the Tata Institute of Fundamental Research in Bombay and the Atomic Energy Commission in 1948, serving as its first chairman. In 1948, Nehru led the appointment of Bhabha as the director of the nuclear program and tasked Bhabha to develop the nuclear weapons soon after. In the 1950s, Bhabha represented India in IAEA conferences and served as president of the United Nations Conference on the Peaceful Usage of Atomic Energy in Geneva, Switzerland in 1955. Time, he in, during this time, he intensified his lobbying for the development of nuclear weapons. Soon after the Sin-Indo War, Bhabha aggressively and publicly began to call for the nuclear weapons. Bhabha gained international prominence after deriving a correct expression for the probability of scattering photons of electrons, a process now known as Bhabha scattering. His major contribution included his work on Compton scattering, R process, and furthermore the advancement of nuclear physics. He was awarded Padma Bhushan by Government of India in 1954. He later served as the member of the Indian Cabinet's Scientific Advisory Committee and provided the pivotal role to Vikram Sarabhai to get up the International Committee for Space Research. In January 1966, Bhabha died in a plane crash near Mont Blanc while heading to Geneva, Austria to attend a meeting on the International Atomic Energy Agency's Scientific Advisory Committee.
Bhabha was working at the Indian Institute of Science. There was no institute in India which had the necessary facilities for original work in nuclear physics, cosmic rays, high energy physics, and other frontiers of knowledge in physics. This prompted him to send a proposal in March 1944 to the Sir Dorabji Tata Trust for establishing a vigorous school of research in fundamental physics. The trustees of Sir Dorabji Jamsetji Tata Trust decided to accept Bhabha's proposal and financially responsibility for starting the institute in April 1944. Bombay was chosen as the location as the government of Bombay showed interest in becoming a joint founder of the proposed institute. The institute, named Tata Institute of Fundamental Research, was inaugurated in 1945 in 540 square meters of hired space in an existing building. In 1948, the institute was moved into the old buildings of the Royal Yacht Club. When Bhabha realized that technology development for the atomic energy program could no longer be carried out within TIFR, he proposed to the government to build a new laboratory entirely devoted to this purpose. For this purpose, 1200 acres of land was acquired at Trombay from the Bombay government. Thus, the Atomic Energy Establishment Trombay started functioning in 1954. The same year, the Department of Atomic Energy was also established. He represented India in international atomic energy forums and as president of the United Nations Conference on the Peaceful Uses of Atomic Energy in Geneva, Switzerland in 1955. He was elected a foreign honorary member of the American Academy of Arts and Sciences in 1958.
Nuclear power program. Thus, the Atomic Energy Establishment Trombay started functioning in 1954. The same year, the Department of Atomic Energy was also established. He represented India in international atomic energy forums and as the president of United Nations Conference on the Peaceful Use of Atomic Energy in Geneva, Switzerland in 1955. He was elected as a foreign honorary member of the American Academy of Arts and Science in 1958. Faced the three-stage approaches as follows. The total reserves of thorium in India amount to over 5 lakh tons in the readily extractable form, while the known reserves of uranium are less than a tenth of this. The aim of long-range atomic power program in India must therefore be the base the nuclear generation as soon as possible of the thorium rather than uranium. The first generation of atomic power station based on the natural uranium can also be used to start off an atomic power program. The plutonium produced by the first generation power station can be used in a second generation of power station designed to produce electrical power and convert thorium into U-233 or depleted uranium into more plutonium while breeding gain. The second generation of power station may be regarded as an intermediate step for the breeder power station of the third generation, all of which could produce more 238. Then they burn in the course of producing power. Death. Bhabha died when the Air India flight crashed near the Mont Blanc on 24th January 1966. Misunderstanding between Geneva Airport and the pilot about the aircraft position near the mountain is the official reason of the crash. Assassination theory. Many possible theories have been advanced for the crash, including a claim the Central Intelligence Agency (CIA) was involved in order to paralyze Indian program nuclear program, and an Indian diplomatic bag containing calendars and a personal letter was recovered near the crash site in 2012.
Legacy. After his death, the Atomic Energy Establishment at Mumbai was renamed as the Bhabha Atomic Research Center in his honor. In addition to being an able scientist and administrator, Bhabha was also a painter and a classical music and opera enthusiast. Besides being an amateur botanist, he is one of the most prominent scientists that India has ever had. Baba also encouraged research in electronic space science, radio astronomy, and microbiology. The famed radio telescope in Nooty, India was his initiative, and it became a reality in 1970. Homi Baba Fellowship Council has been giving Homi Baba Fellowship since 1967. Other noted institutions in his name are the Homi Bhabha National Institute, an Indian deemed university, and the Homi Bhabha Center for Science Education, which is in Mumbai and India. In India. At Baba's death, his estate, including Mehrangir, the sprawling colonial bungalow at Malabar Hill, where he spent most of his life, was inherited by his brother, whose name was Jamshed Baba. Jamshed, an avid patron of arts and culture, bequeathed the bungalow and its content to the National Center for Performing Arts, which auctioned the property for 372 crores in 2014 to raise funds for upkeep and development of the center. The bungalow was demolished in June 2016 by the owners, Mita Krishna Godrej of the Godrej family, despite some efforts to have it preserved as a memorial to Homi Baba. Speaking of his achievements, Baba was elected as a fellow of the Royal Society in 1941. In 1943, he was awarded the Adams Prize by the Cambridge University for his work on cosmic rays, and in 1948, the Hopkins Prize for the Cambridge Philosophical Society. In 1963, he was elected the Foreign Associate of the U.S. Academy of Sciences and honorary life member of the New York Academy of Sciences. In 1964, he was made Foreign Corresponding Academician of the Royal Academy of Sciences, Madrid. From 1960 until 1963, he was president of the International Union of Pure and Applied Physics. He was president of the Historic International Conference of the Peaceful Uses of Atomic Energy held under UN auspices at Geneva in August 1955. Baba was president of National Institute of Sciences of India in 1963 and president of the Indian Sciences Congress Association in 1953. He was awarded the title of Padma Bhushan by the Government of India in 1954. This was the end of presentation of T1, which is from the section P1it.